So if you have the x value, which is right here, there's the x value. You plug in 2. What is f of 2? 2. So that right there is the point. Are you okay with plugging that number in and getting 2? Yeah. You good with that? So when you find the slope, you need to use the limit definition of derivative right there. The a value is what? 2. So you have 2 plus h and f of 2. When you plug things in, you end up with this. Now, why was a table used right here? Why was a table used?
Did you hit a wall?
Yeah, we hit a wall. Exactly. You don't know.
How do you simplify to there?
How did we simplify to there?
Yeah, I get how we.
The function is this, right? That's the function.
Yep.
So you're plugging in 2 plus h for what?
X.
Yes, you're plugging in 2 plus h for x. So that's how you got this right here. And then we plugged in 2 before, and what did we get? 2. That's that green right there. So you simplified a little bit. All you have, the only thing to simplify is what's 1 minus 2 is negative 1. That's it. So then you have to use a table, and then you get an approximation right there. That is your point or your slope. What is that? You found the point over here, so what did you just find out?
Slope.
The slope. So you have all the information you need to use what form of a line. What form do I like you to use? Now this is y equals mx plus b. I really like this one a lot better. I would love you to stop there. Unless I specifically tell you to go to slope-intercept form, use point-slope form. Use point-slope form, please. And so there's certain handles that you can look to have. If you're doing a polynomial, first of all, is this a polynomial? Is that a polynomial that we're taking? Is that a polynomial? It is a polynomial. Anytime you do a polynomial, you will have a nice answer. There might be fractions, but you will have a nice answer, meaning you're always going to get to a point where you can cancel h. If you can't cancel h, something has gone wrong. So a great signpost is getting from this line to this line right there. This to there, what's the only thing that happened? It canceled what? H got canceled right there. Now you can plug in 0 for h. If you can't do that, then something has gone wrong in the algebra. You have to be very careful with the algebra on this one. Be very, very careful. That's all I really can help you with on that one. Now, do you see how this was multiplied out? This is probably the most challenging part, this part right here. You see this? That was doing x plus h minus 3 squared. How many terms are in there? There's 3 terms in there. So when you multiply it out, you just have to make sure you keep track of everything. You have x plus h times x plus, there's 3 terms in there. So you have 9 different pieces. You have to be very, very careful. Add like terms. We're doing very similar types of algebra in BC calculus, and it's still hard. It's still hard. What happens if you miss one of those terms? I mean, I think over on the board yesterday somewhere, doing this one, instead of canceling the 18s, like you see the 18 there and the negative 18 right there? I think some of you had 2 positive 18s and it was like 36. And I saw you over there like, why is there 36? The 36 needs to not be there. And that's right, it should go away. It should be opposite signs.
At times during the like one point during the homework.
Here, you see that negative sign? Oh, that negative sign. Is it frozen?
No, it's just not.
It just, does it actually, it's just moving and putting it in a different place. That's helpful. This negative sign, you see that one right there? That negative sign gets distributed in, right? It gets distributed into all of those terms. You have to be very careful about that negative sign. Very commonly not done. People add it together, they drop it, they don't put the parentheses in. You see the parentheses right here? What happens if you don't put those parentheses in? Only the first term gets flipped. The other ones don't, and then it doesn't work. Okay, everybody find a piece of the board. You guys got negative, I probably don't want it in highlighter.
It was a negative 4. Oh,
negative 8.
That'll do it.
Yeah.
You started with the wrong one.
Oh, that'll do
I
it.
started with 4.
That'll do. Really get to a point, when you do this out, what's the wall you run into? You end up with the limit as h goes to 0 of what? Negative 2 log of what? 5 plus h plus 2 log 5, like that, all over what? H. So you need to plug that into your calculator. What is that going to look like? y1 is equal to, parenthesis, negative 2 log 5 plus h, right? Plus, you can just write 2 log 5, close parenthesis, divided by h. And in this case, when you plug it into your calculator, those h's are x's. You can do that. What you put parentheses, just Noah, so this is a good example. You put in parentheses around this, which is fine, right there. And then you put parentheses around the whole, like this log as well, like that, which is fine. But then you forgot the bigger ones. You have to have a set around the entire top, because what you were doing was effectively this thing plus this thing, only the second thing over h. That's why your numbers weren't coming out correct. That's why it was coming up a little weird. I didn't give you the function. No function associated with this. I could ask you, estimate f prime of 1. There were several ways you could estimate it. What was the way I wanted you to estimate f prime of 1? How do you figure out the instantaneous rate of change when you're given a table? You've done this before. Chris?
One you're on, one after.
Yes, the one you're on and then the next one. You're finding the slope between those. So f prime of 1 is going to be equal to what?
7. Yes, 7.
8 minus
1,
over,
2 minus 1.
which is, yes, it is 7. I just want to show you, have you say where it comes from. There were other ways you sometimes see, which is like averaging before and after, or just doing the point before and the point after. What I want you to default to is where you are in one step to the right. One step to the right. That's what I want you to default to. That would be huge. Okay, let's add in one little thing here. It's asking you on this one not for a derivative. It's asking, you're going to have to find a derivative, but what is it asking you to find on this one?
Equation.
The equation. What do you need for an equation? Point and? What's the easier one to find? Usually, yeah, using point slope, but point and slope.
The easier one is the point, right?
Y minus y1 is equal to m times? Okay, go. Do this one. No calculators. No one touch your calculator.
I'm not good with cosine.
Oh, I get to mess up some parameters. Oh no, I don't use my calculator.
So now, hold on, no, but you're looking, what the slope is the number between right there. So if you make a table, what did you guys think this, what is the point, everybody? Tell me what the point is, Chris. It's pi over 4 comma what?
3 divided 2 over 2 plus 2.
Like this, right? So you did that.
Yeah.
And what did you guys get for your slope? What did you guys think it was about?
Negative
2 point what?
2.1.
2.1 what?
2.
1, 2, something like that?
Yeah.
Maybe 1, 2, 5?
I would say
It's between those two, right?
2.1215.
1, 2, well, it's halfway between those two, so it's going to be, yeah, like, let's just leave it like this. Sure. If we did that, do we have enough information to write the equation of a line?
Yeah.
Yeah, another way to write that point is pi over 4, comma, 3 root 2 plus 4 over 2. So what's it going to be? Y minus 3 root 2 plus 4 over 2 equals negative 2.12. You want to average those two, what do you get? 0.5 times x minus what? Pi over? So that would be your equation of that tangent line right there. That would be it. It is challenging to type this limit into your calculator. If you type it in, you literally can write out y1 equals parentheses. So what did you have? 3? Is it 3 cosine? What is it?
3 cosine.
So 3 cosine of pi divided by 4 plus 2, right? And then what is it? What do you add to it? You add something to it? Kids, what do I need your help here. Do you add or subtract? Minus what? Cosine of what?
Minus 3 cosine.
Is it minus 3 cosine pi over 4? What's the equation of this thing again? It was 3 cosine of pi over 4?
Yeah.
3 cosine of pi over 4.
Plus 2.
Well, it's the plus 2 and the minus 2.
Yeah, they'll cancel. Yeah.
They cancel, they go away, right? So when you're doing, it's actually plus x right here. So this is what you end up plugging into your calculator right there. The plus 2's, they go away. You could write it out before you type it into your calculator and like, look, these are the outer parentheses for the numerator right here, right? So they protect everything that's in there. Not protect, but they group everything together. Yes, Chris? What cosine of pi over 4 is because you're going to need to know what the point is. You can't use cosine in your final answer.
Yeah.
Making your table, that's fine. Totally fine. Totally fine. Totally fine. So let's practice a little bit. Let's practice a little bit here. Limits, limits, and limits. Let's see if we can remember what we do here. So try this one on your own at your desk right now. Try that one on your own at your desk.
Try factor.
Yes. So when you do factor this, the limit as x goes to 2 of, can you factor anything?
No.
No, there's nothing to factor?
Yeah.
Yeah, I mean, you try to factor, maybe you'd want to factor out the negative 3, but then you get negative 3x squared.
Plus 4 over 3.
Well, actually, it's going to be minus 3 over 4. Or 4 over 3, you're right. Minus 4 over 3.
Okay.
But does that help you?
No.
It doesn't help you. You really want to cancel out that x minus 2. You really want to cancel out that x minus 2, correct? Okay, you can't cancel it out. So at this point, what would you have to do?
2.
You have to make a table. So do that for me. Let's do this table again. Come on. I'm serious.
I know.
Our calculator?
Yeah.
Alright.
Do your table here. It's important that you do it for this one. What do you think it's going to be? No one has it? Lindsay, what did you get?
I got like really weird numbers.
Good. So what did you get? What did you get on 2.001? On immediately to the right, what did you get?
Negative 8,012.
8,012?
Yeah.
What did you get immediately to the left?
7,988.
88. Okay, so if I asked you to graph this function right here, what could you tell me happens at x equals 2? What happens at x equals 2? What is there? Nope. Can you cancel x minus 2? No, so therefore what is it?
Asymptote.
Yes, what type of asymptote?
Vertical.
This is a vertical asymptote. What's the power of the x minus 2? 1. That's an odd number. So when you graph this, what's happening at x equals 2? What's happening at x equals 2?
Infinity. What is that?
One side it goes up and one side it goes what? Down. It's an asymptotic discontinuity. So I have a question for you. What's the slope of the tangent line at x equals 2? Does it exist?
No.
No. So what's the slope of the tangent line at x equals 2? Does not exist. So when you do a table, sometimes you're going to get totally divergent numbers. Do you see how kind of symmetric that is? One's super negative and one's super positive about the same amount. That can mean you have oh look, you know that there's a vertical asymptote there. So can you have a tangent line there? No, you can't. You have a vertical asymptote there, but you can't have a tangent line. Does that make sense?
Yeah.
If you plug that into your calculator, you can graph it. It might go the other way, but the point is it goes like this or like this. Can you do a tangent line there?
No.
What's the limit as x goes to 2? It's a positive infinity from the right. Sorry, negative infinity from the right. Positive infinity from the left. So it actually goes up the other way. It goes, remember, look at those numbers. It should go up like that and, sorry, up on the other side, sorry. It should go what? Up and down. You can see that from the table. What about this one? This looks similar, but what should you always check first? Yeah, so can you factor the bottom?
Yeah.
X plus 3 times?
X minus 3.
What can you factor out of the top?
5 and get x minus 3.
And does something cancel?
Yep.
If you cancel this, what do you end up with? The limit as x goes to 3 of 5 over x plus 3. Can you plug in 3?
Oh, yeah.
So what is it?
5 over 6.
Done.
With a hole at 3.
Yeah, so the limit, remember, if you're traveling along and there's just a hole, do you still have a limit there? Yes, you still have a limit there because the left and right hand, are you approaching the same thing? So a hole, you can still have the limit, but if there's a vertical asymptote, your tables will go berserk. What happens if you plug in 1.99999? You get closer to 2 from the left. What can you tell me about the number? If you go closer on the left, like 1.9, don't use your calculator. It's going to get bigger. Exactly. And if you go 2.0000001, it's going to get smaller, real negative. So sometimes you get nice tables. Like, that's great. It looks like it's getting closer together. And will we learn the algebra to do this by hand? Yes. But right now, we really only know one little tiny thing about polynomials. Are all functions polynomials? Look at the board. Are all functions polynomials? Cosine. No polynomial has cosine. No. 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 No.